So welcome to Dividing Radicals Part 2, and from what I hear, not only my students are watching the videos, but many others. So welcome to all of you that are watching my videos. So what we're going to look at now is, yesterday when we did dividing radicals, we had only monomial denominators, which had a single term. But today, we're going to look at binomial denominators, and you have to do something different when you do that. The process of rationalizing the denominator involves multiplying the numerator of the fraction and the denominator by the conjugate of the binomial denominator. And most of you are going, conjugate? What the heck is that? Like some weird fruit? No, sorry, not. So we have to talk about what the conjugate is. So take out another piece of paper. We're going to do a little discussion about what the conjugate is and why we need to multiply by the conjugate. If you have a binomial like root 5 minus root 2, its conjugate is root 5 plus root 2. So basically what you do is you change the sign between the two radicals. If this had been positive, that would have been negative. And you're like, well, why do we have to multiply by the conjugate? Okay. Basically what we want to do when we rationalize the denominator in a question is we want to end up with no radicals left in this denominator. But when you're multiplying by binomials, we have to distribute. We have to go root 5 times root 5 and root 5 times root 2. So if I do that, root 5 times root 5 is 5. Root 5 times root 2 is root 10. Negative root 2 times root 5 is negative root 10, and negative root 2 times positive root 2 is negative 2, because a negative times a positive is a negative, and root 2 times root 2 is just 2. Now if you look at these middle terms, they're radicals, but one's positive and one's negative, and they're exactly the same. So they cancel out. So I'm left with 5 minus 2, which is actually 3. So when you multiply by the conjugate, you end up eliminating the radicals and you end up with some kind of whole number answer, which is what we want to do in a question where we're dividing and we're rationalizing the denominator. We want to get rid of the radicals in the denominator and end up with no radicals at all. So just a couple quick other things. If I have 2 root 3 minus 8, its conjugate is 2 root 3 plus 8. If I have square root of x minus 7 square root y, then its conjugate is square root of x plus 7 root y. If I have 4 root 5 plus root 7, its conjugate is 4 root 5 minus root 7. So there's a bunch of different conjugates, because the first thing you're going to have to do is come up with the conjugate before you can do any work in the problems that we're going to look at. So I'm going to grab a pencil here and we're going to get started. Here we go. Okay, so the first thing we have to do to rationalize this first question is we have to figure out what the conjugate is. And we're going to multiply that conjugate by the numerator and the denominator. So in this case, the conjugate of root 5 minus root 3 is root 5 plus root 3. And we multiply the numerator and the denominator by that conjugate. Now remember, this is still a binomial. So now we have to multiply 2 by each of these radicals. So 2 times root 5 is 2 root 5. 2 times root 3 is 2 root 3. Now, if we expand this, root 5 times root 5 is just 5. Root 5 times root 3 is going to be positive root 15. Negative root 3 times root 5 is negative root 15. And negative root 3 times positive root 3 is negative 3. Remember, a negative times a positive, and a root 3 times a root 3 is just 3. Now our middle terms cancel out, and we end up with 2 root 5 plus 2 root 3 all over 5 minus 3, which is 2. Can I do anything else to simplify this? Sure. I can divide 2 into the first radical and 2 into the second radical, because the coefficients on each of these radicals are 2. So if I divide 2 into 2 root 5, the 2's cancel out, and I'm just left with root 5. And if I divide 2 into 2 root 3, the 2's cancel out, and I'm just left with root 3. So there we go. You may be looking at the question and going, oh, so the answer to every radical question is just the conjugate of its denominator? No, that's not the case, and you're going to see that in the next example, so don't assume that. So when we get to the next example, we have to come up with the conjugate here. So the conjugate is root 6 minus 2. Remember, you keep the same terms, but you change the sign between them. Now we have binomials times binomials that we need to multiply out. So root 6 times root 6 is 6. Root 6 times negative 2 is negative 2 root 6. Negative 2 times root 6 is negative 2 root 6. And negative 2 times negative 2 is positive 4. If we go to the denominator, root 6 times root 6 is 6. Root 6 times negative 2 is negative 2 root 6. 2 times root 6 is positive 2 root 6. And 2 times negative 2 is negative 4. So if we start simplifying, in the numerator, 6 plus 4 gives us 10. Negative 2 and negative 2 root 6 gives us negative 4 root 6. And in the denominator, our middle terms cancel out, and 6 minus 4 is 2. But you're not finished here. This 2 can divide evenly into the 10, and it can divide evenly into the 4. So 10 divided by 2 is 5. Negative 4 divided by 2 is negative 2, and don't forget the root 6. So there's the question in simplest form. The next question has a variable in it. It's not solved any differently. You still multiply by the conjugate, which in this case will be 1 plus root x. Now the numerator is easy. 1 times all of this binomial here is just that binomial, 1 plus root x. If we look at the denominator, 1 times 1 is 1. 1 times root x is just root x. Negative root x times 1 is negative root x. And negative root x times positive root x is negative x. Our middle terms cancel out. Our numerator stays the same. And 1 minus x is our denominator. And this is rationalized because you have no radicals left in the denominator. All right. Next question. Again, we're going to multiply by a conjugate to help us solve this problem. The conjugate in this case is going to be 4 root 3 plus root 2 and 4 root 3 plus root 2. That's what we're going to multiply our numerator and denominator by. So if I start multiplying this out, root 8 times 4 root 3. Now remember, that's a 1 in front. So 1 times 4 is 4. Root 8 times root 3 is root 24. Root 8 times root 2 is just going to give us positive root 16 because 8 times 2 is 16. Negative 1 times 4 is negative 4, and root 3 times root 3 is just 3. Negative 1 times 1 is negative 1, and root 3 times root 2 is root 6. So there's our numerator. In our denominator, we've got to expand this. So 4 root 3 times 4 root 3 is 16 times 3 because 4 times 4 is 16 and root 3 times root 3 is just 3. 4 root 3 times root 2 is going to give us 4 root 6. 4 root 3 times negative root 2 is going to give us negative 4 root 6, and negative root 2 times positive root 2 is just negative 2. So if we start simplifying, I'm going to start with the denominator here. 16 times 3 is 48. The middle terms cancel out, and 48 minus 2 is going to give me 46. In the numerator, if I start looking at things, it doesn't look like I have any like terms in the numerator, but I can simplify things. I can simplify the square root of 24. The square root of 24 is 4 times 6. Square root of 16 is just 4. Negative 4 times 3 is negative 12. And this is just negative root 6. So if I finish this up, Square root of 4 is 2. 2 times 4 is 8 root 6. 4 minus 12 is going to give me negative 8, and I have a negative root 6, still all over 46. Now the last thing I can do is I can collect like terms here. 8 root 6 minus 1 root 6 is going to give me 7 root 6. I still have a negative 8, and I still have 46 in my denominator, and there's nothing I can divide into 7, 46, and 8. So my final answer to this question is 7 root 6 minus 8 over 46. So there we go. That's how you divide with binomial denominators. You work with the conjugate. You got to use some multiplying radicals that we looked at a couple of days, and get ready for your assignment.